Bismillah ar-Rahman ar-Rahim. Welcome to Al-Afaq International School Jeddah Virtual Learning Classroom. With you, Ms. Dina Badawi, Physics teacher for Grade 7. Our lesson today is Chapter 4, Lesson 2, Forms of Energy. We'll continue this lesson today. Listen our instructions, listen to the lesson's explanation. Open your textbook, page 117 till page 119. Check your answers and give a star to each correct answer. Our standards: MS forces and interactions, BS2B types of interactions. Objectives: revise the mechanical energy, explain other forms of energy. Okay. In the previous period, girls, in the previous session, we talked about the mechanical energy. And we said, what's the meaning of a mechanical energy? We said it's the form of energy associated with motion, position, or shape of an object. Can you see the page of the book?
Yes.
Yes. So what's the meaning of mechanical energy? Mechanical energy is the form of energy that is associated with the motion, position, or shape of an object. And how can we calculate the mechanical energy? We said it's the sum of the kinetic energy and potential energy of an object. And this object, the object's mechanical energy will remain the same or will remain conserved as long as there is no friction or there is no loss of energy, because if there is friction, there will be a part of energy will be lost as or not lost, or will be changed to thermal energy. But if there is no friction, so or we will ignore the friction, so the all potential and kinetic energy at first will change it to potential and kinetic energy at last, so the mechanical energy will be conserved. Okay, then we just listed the other forms of energy, but we said in this time we will talk about forms of energy that are associated with the particles that make up an object. What's the meaning of this? We said that all objects are made of matter, and matter is the smallest unit of a matter is the particles called atoms. Is what atoms is the atom. Okay, what about the forms of energy associated with these particles or with the particles of objects? There are many forms of energy like nuclear energy, thermal energy, electrical energy, electromagnetic energy, and chemical energy. Okay, let's discuss each one separately. The first kind is the nuclear energy. Nuclear energy, actually, it's a stored energy. So it's a form of potential energy, or it's a type of potential energy, but it's stored in what? It's stored inside the nucleus of an atom. Because in these types of, or in these forms of energy, we will talk about the forms of energy associated with the particles of an object, For example, nuclear energy is the stored energy, is the potential energy stored in the nucleus of the atom. Okay, it's the stored energy in the nucleus of an atom. It's released, this nuclear energy is released during nuclear reaction. During what? Nuclear reaction. We have two kinds of nuclear reaction. One is called nuclear fission. This fission means that the nucleus will be divided, will be split. So in case when the nuclear energy released or stored inside the nucleus, and it will released during a nuclear reaction, during the split of the nucleus, this reaction is called what? Nuclear fission. Nuclear fission will give an energy. Okay, for example, what occurs in the nuclear power plant? In the nuclear power plant, like this in the photo. This nuclear power plant undergoes nuclear fission. It splits the nucleus of atoms to release the stored energy inside this nucleus in a process called the nuclear fission. In a process called what? Nuclear fission. Okay, this gives energy. What this energy will be used? It's used to produce electricity. So again, we are talking about nuclear energy, which is a kind of potential energy stored inside the nucleus of an atom. this nuclear energy, which is stored potential energy, is released during a nuclear reaction. During nuclear reaction, we have two kinds of nuclear reaction. The first one is the nuclear fission. From its name, this means that the nucleus will be split, like what happens in the nuclear power plant. Inside it, there is a split of the nucleus, so it gives energy. This energy will be used to produce electricity in a process called what? Nuclear fission. So nuclear power plant undergo nuclear fission. Okay. What about the second kind of nuclear reaction? Again, we said the nuclear reaction is a process in which the energy stored inside the nucleus is released. Okay, nuclear energy released during a nuclear reaction. The first nuclear reaction we learned is the nuclear fission. Okay, what about the second one? The second one is called the nuclear fusion reactions. Nuclear fusion reactions, this occur constantly in the sun. This is the process that occurs constantly in the sun, is named nuclear fusion reactions. Now, when it occurs inside the sun, it releases a huge amounts of energy. So what is the reaction that occurs inside the sun? Nuclear fusion reactions. In this case, from its name, it's nuclear fusion. The nuclei of atoms join together or fuse together. From its name, it's nuclear fusion. The nuclei of atoms will join together or fuse together to give also a huge amount of energy. Only tiny portion of this energy reaches the earth as heat and light. Of course, the sun gives us heat and light energy. This is a form of nuclear energy or nuclear fusion reaction that occurs due to the joining or fusion of the atoms, of the nuclei of the atoms, okay, which release huge amount of energy and only reaches the earth only a tiny portion. It's okay. So we have two kinds of nuclear reaction. Again, what's the meaning of nuclear energy? Nuclear energy is the stored energy, is the potential energy inside the nucleus of an atom. It's just stored. How can it be released? During a process called nuclear reaction, okay, to release this nuclear energy. We have two kinds of nuclear reaction. One is called the nuclear fission, in which there will be splitting of the nuclei, while this occurs in nuclear power plant, and it releases energy used to produce electricity. While the other reaction is called the nuclear fusion, which occurs inside the sun, and in this case, the nuclei of atoms fuse or join together and releases a huge amount of energy. Okay, let's make this how nuclear fission and nuclear fusion are similar and how they are contrast. And they meet together in which part, and they are different in which part. Compare and contrast nuclear fission and nuclear fusion. Can you participate with me, girls? Both of them are what? Both of them, we can say both of them release energy stored in the nuclei of atoms. Yes, they are both nuclear reactions that release energy stored inside the nuclei of atoms. In case of nuclear fission, this energy is released by splitting of nuclei when the nucleus split apart. But what about nuclear fusion? The energy releases when the nuclei fuse together or join together. Example of nuclear fission, what occurs in the power plant to produce energy, to produce electricity. Example of nuclear fusion, what occurs inside the sun to produce a huge amount of energy that reaches us in the form of heat and light. Okay, so this is the first form of energy that is associated with the particles of an object, nuclear energy. Any question in the nuclear energy? Is it clear?
Yes, Miss.
Yes. Excellent. Okay. The second kind is the thermal energy. What's the meaning of thermal energy? Thermal energy is the particles that make up objects are constantly of motion. Yes? Particles. Again, if we are talking about matter, solid, liquid, gas. Yes? We have the particles or the atoms inside these states or inside these objects are in motion, so they have kinetic energy. So they have what? Kinetic energy. Also, due to their arrangement inside these objects, the arrangement of the objects, the arrangement of the particles inside these objects, they have also kinetic energy. So the total kinetic energy and potential energy of the particles in an object, this is called what? This is called thermal energy. So what's the meaning of thermal energy? Thermal energy is the total kinetic energy and potential energy of particles in an object. Take care, I'm talking about particles. I'm talking about particles. But in case of mechanical energy, we said it's the energy associated with the shape, position, or motion of an object, And we can add both kinetic energy and potential energy of the object to get the mechanical energy. But here, in case of thermal energy, we are talking about it's the total kinetic energy and potential energy of the particles in an object. Okay, girls? What about if I increase the temperature of an object? You see, when we are boiling water, when we boil the water, the water will make bubbles and will move fast and fast, yes? So when increasing the temperature of an object, more thermal energy the object will have. We say that it has more thermal energy, yes? And the particles will move fast. So what will increase when the particles move fast? Their which kind of energy? Their kinetic energy. So increasing the temperature, increasing heat means more thermal energy as the kinetic energy is increased. Because with increasing heat, or the higher the temperature, the particles move faster and faster. This faster movement will gain greater kinetic energy, will increase the kinetic energy, so higher temperature, so increase the thermal energy. That's why we say a pot of water at 75 degrees Celsius has more thermal energy than the same amount of water at 30 Celsius. Okay, girls? So we are talking about thermal energy. What's the meaning of thermal energy? Thermal energy is the sum of kinetic energy and potential energy of particles in an object. This is called thermal energy. The higher temperature of an object, the more thermal energy the object has. Because if it has higher temperature, if I apply heat, it will cause what? It will cause these particles to move faster, so its kinetic energy will increase, so it has more thermal energy. Okay, is this clear?
Yes.
Okay, this is thermal energy. Take care, total kinetic energy and potential energy of the particles of an object, thermal energy. Okay, and we can sometimes say it thermal energy, it's like heat energy. It's okay, but it's not exactly the same. But we say when we apply heat, this will get more thermal energy. Or if an object has more thermal energy, it's hotter than other object with less thermal energy. Okay?
Yes.
Okay, what about electrical energy? The third kind, or the third form of energies that are associated with the particles of an object is the electrical energy. From its name, this electrical energy is the energy of the electric charges. Energy of the electric charges gives electrical energy. Depending on whether the charges are moving or stored, electrical energy can be in the form of kinetic or potential energy. Again, girls, do you remember when we said the two basic types of energy are kinetic energy and potential energy? These are the two basic kinds. So I can, after that, say that any other kind or any other form of energy, if it has motion, so it's kinetic energy. If it's at rest, it's potential energy. Or if it's stored, so it's potential energy. So electrical energy is a kind of, if it's just stored, so it's potential energy. Or if it's moving, the electric charges, these electric charges are in motion, like the electric current, so it's considered kinetic energy. So what's the meaning of electrical energy? Electrical energy is the form of energy that is associated with the electric charges. The electric charges. Electrical energy is the energy of electric charge. Okay, girls, the energy of electric charge. For example, what? For example, the electrical energy in batteries. Which batteries there are positive and negative, or electrical lines, or run devices such as computers, handheld games, and digital players. So all the forms of energy or the form of energy that is associated with charge, this is called electrical energy. Okay, girls. So until now, we learned about thermal energy, electrical energy, nuclear energy. What about the fourth kind, electromagnetic energy? Take care. In the previous page, electrical energy is the one associated with the electric charges. For example, you have to know the lightning. You know the lightning that occurs when it's raining. The lightning is a form of electrical energy. Take care. The lightning is a form of electrical energy, and it has positive and negative charges. This is electrical energy. And take care, this lightning can cause shock if it touches anybody, okay? And if it's so strong. So lightning is a form of electrical energy. Electrical energy. What about electromagnetic energy? Electromagnetic energy actually are a form of energy that travels through space in the form of waves. These are electromagnetic waves. Electromagnetic waves. We'll discuss this in details, inshallah, next year in grade 8. The electromagnetic energy and the electromagnetic waves. These are waves that can travel either through vacuum or through medium. Okay, it can travel through vacuum or through medium, and it's accompanied by the release of electric energy and magnetic energy. So electromagnetic radiations or electromagnetic energy. And we learn that electromagnetic waves have a spectrum, which is starting by the radio waves, infrared waves, microwaves, radio waves, microwaves, infrared waves, light, visible light, okay, ultraviolet waves, X-rays, and gamma rays. These are the components of the electromagnetic spectrum. Starting by what? The first one is the radio waves, then the microwaves, infrared rays, light, visible light, the visible light. This is electromagnetic waves. These waves associated with the energy is a form of energy that travels through space, which is named electromagnetic energy. The source of these waves is vibrating electric charges, and there must be vibrating electric charges or electric charges that vibrate, creating waves and then making a magnetic electric field and magnetic field and form each other continuously, that they will form electromagnetic waves and electromagnetic energy. Okay, and of course these waves do not require medium. They can travel through space or through vacuum. Okay, this is why we can see the sun and stars, even they are in space, but we can see them because the light can travel in this space or through this space as a form of electromagnetic waves. Okay, also the microwaves, as we said, you use to cook your food, and X-rays doctors use to examine patients are also of types of electromagnetic energy. Other forms of electromagnetic energy is include ultraviolet rays, infrared or heat waves, and radio waves. The cell phones and the mobiles that we use are all using microwaves. So all of these are called electromagnetic waves, creating electromagnetic energy. So when I ask you, what is the kind or what's the form of energy in light or invisible light, this is called electromagnetic energy. Okay, when the light you see is one type of electromagnetic energy. But what about lightning? Lightning, as it has electric charge, so it's a form of electric energy. It's a
Energy.
form of electrical energy. So take care of electrical energy and electromagnetic energy. Electromagnetic energy is the energy or form of energy that travels through space in waves. And we have electromagnetic spectrum. We'll discuss in details next year, inshallah. But electrical energy is the energy associated with the, it's the energy associated with the electric charges, like that of the batteries, like that of the electric lines in the devices, and of course in the lighting. Okay? Okay, girls? Okay. Then the
Okay.
last kind is the chemical energy. Chemical energy, in brief, is the energy stored in chemical bonds. So it's a form of kinetic or potential energy. When I say it's the energy stored in chemical bonds, so it's a form of potential energy. So what is the chemical energy? Chemical energy is the potential energy stored in chemical bonds. It's the potential energy stored in chemical bonds. Like what? Like what considered chemical energy? The energy, the food that we eat, it has chemical energy because it has uh, chemical bonds inside its particles. So these chemical bonds can store energy in the form of chemical energy. After that, when I eat it, it can be changed back. I will move, I will make anything, so it can be changed to kinetic energy, okay? But at first, this food has a chemical energy, okay? Also, the matches that you use to light the candle, these matches has stored chemical energy, okay? The cells in our bodies, the cells, our cells, our body cells has energy stored in it. This is called chemical energy. You will learn ATB, and also in grade 9 you will take all of this in details. This energy is stored energy called chemical energy, okay? So chemical energy is the potential energy stored in chemical bonds. Chemical bonds are what hold atoms together. You know, of course, what's the meaning of chemical bonds? It's the bonds between atoms or between particles, okay? When these bonds are broken, this stored energy will be released, okay? For example, bonds are broken in your cells and release energy for the body to use, okay? So we learned it here, the 5 kinds of energy that is associated with the particles. Again, what are they? Nuclear energy, electrical energy, electromagnetic energy, chemical energy, and thermal energy. So when I ask you, what are the kinds of energy associated with the particles of an object? You will tell me what? Who can say? Forms of,
Thermal energy.
yes. Yara, please answer.
Nuclear energy, thermal energy, electrical energy, electromagnetic energy, chemical energy.
Excellent. Thank you so much, Yara. Okay, let's answer the questions inside your book. Open your books, page 100. We already answered 117, so we'll answer now page 118. Page 118. Are you following, girls? Let's answer. Okay, look at this picture. Many objects in these restaurants have more than one form of energy. Circle 3 objects, describe 2 forms of energy each object has. Take 1 minute and decide. We have many objects in this restaurant and can have different forms of energy. Okay, if I talked about this waitress, this girl, this waitress, what, give me 2 kinds of energy she has. Okay, Jana. Jana,
Miss, I was going to say about the cake.
about the candles,
The cake.
about what?
It has
The
the
cake.
cake. It has
Cake,
chemical
excellent.
energy.
It has what?
Chemical energy.
Chemical energy, good girl. Excellent. It has chemical energy, and also it has another kind of energy, not for the particles, for the object itself. Can you? When I lift it up like this, the waiter lift it up. So it has which kind of energy?
Mechanical?
Mechanical. Who said it? Excellent.
Me.
Jana?
Yes.
Excellent, Jana. Mechanical energy. Why? Because it has, due to its position, It has stored
Yes.
potential energy, and also it's moving, so it has kinetic energy. So it has both potential and kinetic energy, so it has mechanical energy, okay? And of course, it has chemical energy because it's a food. And if I talk about this candle, the candle has light energy, yes? The light in the candle is electromagnetic energy. It's okay?
Yes.
So if I talked about this cake is food, so it has chemical energy. This cake is moving, it has kinetic, and due to its position, it has potential, so it has mechanical energy. It has a candle, this candle has light, yes? It has electromagnetic energy, excellent. Light, so electromagnetic energy, excellent. What about this waitress? Inside her body cells, we have, she has which kind of energy?
Miss the cell phone.
She has what?
Miss the cell phone يعني that she's
The cell phones, yes. Okay, the cell phone that she sends has electromagnetic energy. Okay, the cell phones run on the electric energy on the batteries. All the batteries, cell phones has electromagnetic energy. I'm talking about this girl. Inside her body, there is a chemical energy. Yes, and since she is walking, she has kinetic energy, so mechanical energy. Okay. And we talked about the cake, and we talked about the cell phone. يعني الموبايل has electromagnetic energy. لو عنده microwave has microwave, so electromagnetic energy. So all of these are examples. So if we look around us, we will find many and many examples of forms of energy: electrical energy, electromagnetic energy, kinetic energy, potential energy, mechanical energy, and so on. Okay, girls? Is this clear?
Yes.
So we can circle the cell phone, we can circle this waitress, we can circle the cake. Excellent, girls. Thank you so much. Okay,
Miss.
the next page.
Miss circle the wedges.
Yes, we said the waitress, she has inside her body chemical energy. Yes? Which we said inside our bodies, the chemical bonds inside the atoms of our bodies has chemical energy. Yes? And since she is walking, so she has kinetic energy, so mechanical energy. Okay?
Okay.
This is two kinds of energy. The cell phone has electromagnetic energy. The cake, we said the cake has mechanical energy, chemical energy, and the light of this candle is electromagnetic energy. Okay, all of these are examples.
Miss, what about the light?
Of course, the light is electromagnetic energy. You can choose any kinds, girls, again. The light is a sort of electromagnetic energy. Okay? Okay, girls, then the next page. Assess your understanding. Why do particles of objects have both kinetic energy and potential energy? Because these particles, okay, girls, please try to answer this, okay? Try to answer this question alone. Take 1 minute. Why do particles Did you think about it? Why do the particles of objects have both kinetic energy and potential energy? If they are, these particles are in motion, yes, are constantly in motion, so they have what?
Miss because miss because these forces يعني are driven by the force of motion.
These particles, because the particles, we are talking about the particles inside the objects, the atoms. The atoms.
Miss driven by the
These
force
atoms
of
or these particles are in motion. They are continuously in motion.
yes,
So they have kinetic energy, and they have a specific arrangement. So they have certain positions. So they have potential energy.
potential
Okay.
energy.
So
Zero.
since they are in motion, constantly in motion, they have kinetic energy, and
Yes.
also they have potential energy as a result of their specific arrangement in the object. Okay. What
Yes.
about letter B? The energy you get from eating a peanut butter And jelly sandwich is the
Chemical energy.
what? Yes?
Chemical energy.
Excellent. Who said it?
Rimas.
Who?
Me, Rimas, yes.
Remas. Excellent, Remas. We said the energy stored in food, of course, it's a chemical energy. What about the last question? Now I know the forms of energy associated with particles of objects include what? Who is?
Nuclear energy, thermal energy, electrical
I
energy,
want. Oh, okay.
electromagnetic energy.
Okay.
and
One
chemical.
by one. Can I have Nada? Can you say one? Nada? Okay. Shams? Hazar? Hazar. Okay. What are the forms of energy associated with particles of objects? Hazar? Where are you, Hazar? You raised your hand and you didn't join. Okay, who is ready, girls? Haneen.
Miss me.
Haneen, can you?
Yeah, miss the electromagnetic energy.
Yes, another one. Electromagnetic. Another one. Haneen.
The chemical energy.
Chemical energy. Thank you, Haneen. Another girl.
Miss me, I can.
Okay, who are you? Aisha?
Rimas. No, I'm sorry.
Rimas. Okay.
Yes, I can.
Nuclear energy,
Nuclear energy.
thermal energy,
Thermal energy. Excellent. Alia, can you continue? One is remained.
Electrical energy.
Electrical energy. Excellent, girls. These are the 5 forms of energy that are associated with the particles of an object. Okay, this is our lesson for today. We finished all the questions inside the book. So again, let's revise quickly what we said. We said that if I'm talking about the energy stored in an object, this is called potential energy. And we have 2 kinds of potential energy. Gravitational potential energy, it's the stored potential energy due to its position. And I can calculate it by mgh. Its unit is joule. What about the elastic potential energy? Is the stored energy in elastic objects due to their distorted shape, either stretched or compressed. We can calculate it, but it's not for you, the calculation. Yes, its unit is joule, okay? What about the energy of an object due to its motion? This is called kinetic energy. We can calculate it by half m mass times speed to the power 2, okay? What's the meaning of energy? Is the ability to do work. So object has the ability to do work due to its motion. This is called kinetic energy. What about the sum of both kinetic energy and potential energy? This is the mechanical energy. It's the sum of the potential energy and kinetic energy of an object. And it's the form of energy associated with the object's shape, position, or motion, okay? This is the mechanical energy. What about other forms of energy that are associated with the particles of an object? The particles of an object, these are the electrical energy, energy of electric charges, electromagnetic energy. Electromagnetic is the form of energy travels through space in waves due to electromagnetic waves. Chemical energy stored in chemical bonds. Thermal energy is the sum of potential energy and kinetic energy of the objects of an object, of the particles of an object. What else? Nuclear energy is the energy stored inside the nucleus of an atom, and this nuclear energy can be released by nuclear reactions, which either nuclear fission or nuclear fusion. Nuclear fission if splitting, nuclear fusion if joining, okay? Thank you so much, girls. Any question in our lesson?
No, miss, thanks.
No, thank you.
Okay.